Let's graph it out. It's going to come up at 4 instead. X squared, and then plus 4. It's going to move vertically up 4 units. There's a restriction. Again, x is greater than or equal to 0. It's that portion right there. So it's just by looking at the graph, you can tell what the domain is for the f inverse function. As such that x value is going to be greater than or equal to 0. And what's the range of the f inverse? Is such that y is going to be greater than or equal to 4. Just by looking at the graph. And show that the slopes are perpendicular to each other. Before we do that though, I'm going to go over the line y equals x right here. Just to show you that it's inverse function. Y equals x. And here's 4 right over here. And these are mirror of each other, or reflection, the property of reflection, part of the transformation process. Okay. Show that slopes are perpendicular to each other. Okay, so let's try to work this out. We're going to do the f prime of x here, part D. F prime of x is equal to 1 over 2 square root of x minus 4, changing this to a radical form, bring it on down, and then make it 1/2, negative 1/2, and then it goes to the denominator. So what's f prime of 5 this time? It's equal to 1 over 2 times square root of 5 minus 4 is 1 is equal to 1/2. Let's do the f inverse function this time. F inverse of x prime, the derivative of that is equal to 2x. At x equals this time 1, that's going to be 2 times 1 is equal to 2. You notice that 2 and 1/2 are reciprocals of each other. They give you the inverse function. You can actually create the inverse function from f to f prime in this case. I'm going to do it for you right over here on this problem. Okay. It's a review of algebra 2/pre-calc. Square root of x minus 4. Step 1, you set y is equal to square root of x minus 4. And then interchange the x and y. That's step 2. X is equal to square root of y minus 4. Step 3, we're going to try to solve the new y right there. So you have to take the square of both sides. That becomes x squared is equal to y minus 4, because the square and the square root cancels. So y is equal to x squared plus 4, moving the plus 4 to the right side. That's your new function. We call it f inverse of x. It's x squared plus 4. Let's do this one more time. Step 1, just call it fy, f of xy. Step 2, interchange the x and the y. Step 3, solve for your new y. Step 4, call your new y f inverse of x. And of course, there's a restriction. The x value cannot be, has to be greater than or equal to 4 right there. And for that value, x has to be greater than or equal to 0. Okay. Let's look at the intuition of how to get the inverse function. Okay. The function says blah, 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 whatever it is. You subtract it, subtract 4, and then square root it, whatever it is. So whatever x is right here, we first subtract 4 and then square root it. So we're actually going to go backwards on this, and it's pretty easy to go backwards on this. Inverse operation square rooting is blah, 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 whatever it is. We, instead of square rooting, inverse operation squaring, and then subtracting 4, going to add 4. So we end up with whatever it is, squaring it plus 4. Remember, these are inverse functions, so they have all inverse operations. Some of the functions are one-to-one functions, that is, are going to be hard to solve, so you have to use this formula given at the first page. That will help you to do some of your problems. Okay? Thanks, guys. Good luck on your homework. Again, this part of calculus is usually reserved for BC students, and we're trying to find the slopes of inverse functions. Take care. Bye.